Coercion and Truthiness. So this should be a pretty good break from loops. This is a little more like kind of like high level academic, and we get into kind of the quirks of JavaScript. So first of all, what do you think of when you hear the word coercion? Forcing something, exactly. What about truthiness? Is that a real word?
I didn't know that was a word. Yes.
Is it a word? Truthiness. Informal. So probably not Scrabble word. The quality of seeming or being felt to be true, even if not necessarily true. That makes sense, right? And there's this picture of Stephen Colbert here. Something he would definitely say. Yeah. Cool. So it's like, it's just whether something is truthy or not, right? We'll get into like what that means. But let's focus on coercion. So coercion is like, it really is like it's forcing something. Think of it. The word that I like better is conversion, right? Converting something from one thing to something else. Okay. And this applies when we're talking about types in JavaScript. And what are types? What are types? There are 5 types. There are 5 primitive types in JavaScript, right? And let's go over them. So let's see, primitive types of JavaScript, right? What did I just do? Okay. Who knows what they are? What is one type? Yeah. String. Excellent. Number. Yep. Boolean. Great. Undefined. Yes, that's a type. It's weird. It's a little weird, right? What's the last one?
Object?
Close. So that is a complex type. Object. Which we'll go into, I think like next week or something.
Not a number?
Close.
Null.
Not a number. Yes, null. Exactly, that's the last one. There's also array as a complex type. And I think a function is a complex type. Okay, so anyway, these 5 are the primitive types of JavaScript. Okay. And what does primitive mean? Not complex, like basic. And so, okay, what are some examples of strings? It's basically like anything that's surrounded in quotes, right? You can use single quotes. You can use double quotes. You can also use backticks like this. These are all valid strings, and these weird things are just under your escape key. Numbers, right? There's a lot of examples. We have like 0, or like this, or like something like negative numbers, right? And then decimals also. Like these are all numbers. Booleans, there's only 2, right? There's true or false, and that's it. And then for undefined and null are like the weird cousins, right? Where there's only one of each. The only thing that is of type null is null and nothing else. Okay. So the ones we're more used to are the top 3, and so these are the primitive types. And where type coercion comes in, right? Where coercion comes in is when I want to convert something, right, from one type into another type. Specifically, the first 3. If I want to take a number and I want to convert it to a string, or vice versa, we have to use something called type coercion. Okay. So type coercion, right? Basically, like I like to use the word conversion, right? Type coercion converts something from one type to another. Say from one primitive type to another. Okay. Conversion. Like you're converting someone, right? Scientology. Boom. That's basically coercion. Okay. And there are 2 types No pun intended. There are two types of type coercion. One is explicit coercion, and then the second is implicit coercion. And so let's look at a few examples of explicit coercion. Okay. Actually, first of all, let's look at how to like determine the type of anything. Okay. So we'll say let num equals 456, and if I want to get a type of this thing, right? Can anyone take a guess as to how I can get the type of something? Type of. Exactly. If you're curious about the type of anything, just put type of in front of it. Okay? All one word, all lowercase. It's going to console out what this is. And we get that the type of num, whatever is stored in this variable, is a number. Okay? And then so here I'm going to console log the number itself, right above it. Right, 456 is a number. Great. And then what we're going to do is we're going to explicitly coerce this number into becoming a string. So something like this. Right? We're gonna force it to become a string. Okay? And to do that, right, you do this. You literally use the word that you want to coerce something into becoming, and then with a capital letter. So string. String and then num. And so let's say here I'm going to say let stringified, right, is going to be the number, right, 456, except I'm going to coerce it into becoming a string. Okay? And so now if I console log num from here, it should be the same, right? It's still 456. It still looks the same, right? But if I console log the type of stringified. Oh, it should be stringified. We should get string. So what is stringified? Stringified is this number converted to a string. And so now it's like we've a quotes around 456, and the type of that thing is a string. Okay? Now, you might be wondering, like, this looks the same. What's the point of this? Like, why does it matter what type of this thing is, right? Can anyone guess as to why this might be helpful to switch types?
It depends on where you're feeding it to or mapping it to.
Yeah. So it depends on how you need your input to be formatted, right? So, great point. So for example, let's say you have a form on your web page, and the form takes in all this user information about like name, right, address, your age, and all this other zip code, whatever. And what it wants to do is check whether you are at least 21, because you're making a gambling website, right? It wants to check if you're 21. But if the form, right, feeds all the data to you as strings, right, you can't check if the string 21, right, like how old you are. Like let's say you put that you're like 25, right? You can't check if this string is greater than the number 21, right? So you want to make sure that you have consistent typings, right? So you want to make sure that all of your values, wherever is relevant, are coerced to the correct type. So in this case, if someone puts in the word 25 into your form and it comes to you as a string, you want to type coerce it, convert it to a number, and then do some comparison there. Does that make sense? Okay, so let's do that. Let's say I have some string is 25, and I'm going to console log the string, and I'm going to console log the type of the string. Right? So we have 25, and the type of this thing is string. And so what I want to do is I want to say, okay, let's say like numberified, right? Is I want to convert the string to a number. So if I converted number to a string using capital S string, how would I convert it into a number? Number. Exactly, right? There's no no secret. And then so now you're taking string, and you are explicitly coercing that string to becoming a number. So now I'm going to console log this, and console log the type of that. So it looks the same. To us, it looks the same, right? But under the hood, this 25 is a number, and the original 25 was a string. Yes?
So let's say there was a space in the string after 5.
Okay.
So then you go to turn it into a number.
Yeah.
Like, is the actual value of the number 25?
That's a good question. That's a good question. So let's try that, right? I'm going to move this back. What if I put a space after this and I try to convert this into a number? It still works just fine.
Well, it still knows it's not like, how are you double checking the value, like the actual value of your number? Because it says 25 there on the console log on the second one.
Yeah, this thing you mean?
Mm-hmm.
Yeah, exactly. Yeah, this thing is the number.
Okay.
So it's like, okay, what is this plus another 25? It's 50.
Okay.
And what is this thing plus 25? It's weird. We'll get into why this happens, okay? Yeah, there's some unfortunate stuff that happens. Yes.
What if it was 25 years old?
Oh, okay. All right. This is like we're getting into some dicey territory here. So 25 years old. Nan. Nan stands for not a number.
So what did
Not a number. And you know what's weird? Not a number. The type of not a number is number. But it's not a number, right? But it is. So not a number is a number in JavaScript. And that's one of the things that the language gets a lot of flack about. That this is weird. Yeah. Good question. And I wonder what happens if I do this. Yep, that's also not a number. So you can. Yeah, I think you can only put it like around the edges like this. Or like this. Yep, but as soon as you do this, not a number.
That makes sense.
Yeah, that's weirdly makes sense, right? Cool. So this is explicit type coercion, and the reason it's explicit, right? The reason it's explicit is because we are very intentionally taking something and converting it to becoming a number, right? We are explicitly coercing something from being one type to another type. Implicit coercion, on the other hand, is where things change under the hood without you really knowing it, without you explicitly asking it to change. Okay. So, for example,
Kind of like the Z thing.
the Z thing.
Yeah, when you like inputted a number and then you wanted to output how many times Z was. Would that then change?
Yes and no. Yes and no. So here we'll see it here, right? So we're gonna say something we just did, right? We'll say I'm gonna console log. I'm gonna say let result equals, let's say 10 plus 100. And console log. Let's do this. 1 plus 2. Okay. What do you think this is gonna give us? 3, right? 1 plus 2 is 3. Did someone say undefined? All right, it's gonna be 3. Okay, so this is fine. Now what happens if I want to add the string 1 to the number 2? Okay. Who thinks 3? Okay, who thinks undefined? Who thinks not a number? You can't add two things that aren't both numbers. Okay, who thinks 12? Wow, good guess. It is 12. Now, why is this? I don't really know. The reason this happens is because this plus operator has some implicit type coercion stuff happening, where basically it compares the things that's surrounding it. What's surrounding myself? What's around this plus sign? I have a string and I have a number. And if at any point I'm trying to add a string to anything that's not a string, right? I'm going to implicitly type coerce everything that's not a string to also becoming a string. So this thing that's not a number, it is now a string. Or sorry, this thing that's not a string, rather, is now going to be a string. So it's as if we do something like this. Okay? And what's this? So if I say let result equals the string 1 plus the string 2, right? This we all know to be 12, right? Because whenever you add any two strings together, you're just like putting them together, right? That's called concatenation. Okay? If I say hello plus and then space and then world, what am I doing? I'm just putting those two things together, right? That's how you add two strings together. Okay? How do you add two numbers together? You do math, right? If you add two strings together, you just put them together. Now, if you want to put a string and a number together, then what JavaScript will do is implicitly type coerce the number to becoming a string. Okay? And now we get this.
12.
And 12, yes, thank you. So let's look at the type of 12. It's a string. So let's do 100, and I want to add 200. We get not 300, but 100200, the string, in quotes. And that's it. And if you want to make this a number, right, you're going to have to type coerce this thing into becoming a number, like something like this, right? You're going to want to use this beforehand. But if you don't do this, right, they're going to take care of making this a string. That just happens, okay? Now, what happens if we do something like this? We do 1 plus 1 plus 1 plus 1. We know this is going to get 4, right? Unfortunately. Who thinks this is going to give 13? Okay, who thinks this is going to give, let's see, what else? 1, 1, 1, 1. 4 ones. Okay. It's 4 ones. That sucks, right? well, why does this happen? The reason this happens is because you might be like, oh, this should just be like clumped together first. Well, unfortunately, JavaScript goes from left to right, right? Well, specifically, it actually goes from top to bottom, and then left to right for each line, right? It's kind of like going in this direction, right? And in that case, right, we're just gonna do this operation first, left to right. What's the string 1 plus the number 1? It's the string 11, right? It's 1 1 in a string. Okay, so what's 1 1 plus the number 1, right? That's 1 1 1, etc.
So if you change the order of that one being in another.
Yeah, excellent question. So what if you do this?
Yeah.
Really, really good question. Who thinks 1 1 1 1 again? Okay, who thinks 31? That's tough. That's 31. And yeah, so left to right, right? What's 1 plus 1? Well, they're both numbers, so we're just going to add them. So now it's 2. And then what's 2 plus 1 is 3. And then what's the number 3 plus the string 1 is 31. Apparently. Yeah. Oh, sorry.
Oh, if you put parentheses around there.
Yeah. Order of operations. It's like PEMDAS. So what happens if I do something like this, right? Is that what you're saying?
Yeah.
It respects the PEMDAS. Whatever that stands for. Yeah.
So if you have multiplication or division.
Ooh, yeah. Good question. This is getting dicey. So 5 times 5. Excellent question, right? This takes priority over plus.
How does it know that?
How does it know that? Ooh.
Isn't there also like a website where it'll show you like the hierarchy?
Yeah. So yeah. So really good question, right? Like if we're going from left to right, like how is this how is this knowing that this is coming? It mostly goes left to right. So it's first gonna analyze, right, what's going on in that line to see, are there any like parentheses? Are there any like are there multiple operations that are happening that I have to respect some order to? If not, I'm just gonna start from the left and go to the right. And this is not the same in a lot of languages. Like some languages might actually take this and give you back 13. Some languages literally won't even let you do this. Right? It'll yell at you, saying like you can't add this type to another type. Yeah.
What is JavaScript's thought behind implicit coercion? Like
Yeah.
it makes sense explicit
Yeah.
how specifically you want to change this, but is it like, oh, you might be making a mistake, let me just correct this for you? Or
It's a point of contention. It's very controversial. Yeah. So this is just showing you like what happens when you literally go ahead and do this. Don't do this.
Okay.
And again, a lot of languages will literally error out when you try this, and that's kind of like what I prefer. But let's do one more thing. If I do let result equals, let's say like 1, and I want to add like true, and I also want to add like null, right? Now we're not adding numbers, we're adding just strings, right? Strings to a Boolean and null. It's just going to pipe everything together, and the whole thing's going to be one string. I know it's terrible. It sucks, but this is the world we live in. And these have been implicitly coerced into strings. Does that make sense? I mean, it doesn't make sense, but does it make sense? Okay. All right, let's start this lecture. Okay, so we went over explicit coercion, implicit coercion. I'm gonna go over the double equals, right? So far you've seen triple equals. There's also actually double equals in JavaScript. And then we'll do a couple more things. Okay. So let's keep going here. Okay, double equals. Double equals is also a source of implicit coercion, and it's something that you should stay away from. Okay? Avoid, right? Avoid using it because it uses a large set of rules to implicitly coerce values to the same type before comparing them. Okay. So what does that mean? 10. Imagine double equals as like roughly equals. Okay, are these things kind of like basically the same thing, right? 10 roughly equals 10. Yeah, right. They're literally the same thing. So they should at least be kind of the same thing, right? 10 is like the number 10 is roughly equal to the string 10. True, right? They are kind of similar. Now, the string true is basically the Boolean true. No, this actually returns false, which is kind of weird. The empty string is roughly equal to false. It's true. They are roughly the same thing, apparently, which is weird. And then true is approximately equal to the string 1. Yes, it is, apparently. And so this is just like toxic, right? This is really, really hard to remember. And you like, because this is true, you might think that something like this is true. You know what I mean? And you might get some like false positives or true negatives. I don't know. And so like this is like the source of a lot of bugs. And so always try to stick to using 3 equals, a triple equal sign. Okay. I don't know. Next thing you know, like you might this might trigger something that you don't want, right? That's unintentional. So double equals is bad. I think the creator of JavaScript actually like apologized about this. But because this literally exists in the world of JavaScript, we're teaching it to you. But try to stay away from it.
So it's never used?
It's never used.
Okay.
It's never used. It's looked down upon if you use it in like an interview or something. Stay away from it. But and the reason you want to stay away from it is because it uses implicit coercion rules that are hard to kind of like detect.
Is there anywhere where they actually list always exist?
Yes.
There is.
Yeah, I'm sure there is. Let's look for it. JavaScript double equals rules. Double equals equality comparisons and sameness. Okay, so MDN has something for this. Everyone heard of MDN?
Yeah.
Awesome. Cool. It's a really good place to look up JavaScript syntax and just like documentation. Stands for Mozilla Developer Network. So yeah, I mean there's some weird stuff that happens here. But don't even look there. Like don't even try looking. If you want to, you can.
Is the triple equal mark from like a newer version of JavaScript?
It is not. They always both existed. But stick to triple equals because that's like what you see is what you get. Triple equals is like, are these two things literally the same thing, right? And that's much more easier to deal with. And the reason this stuff happens is because, why is this happening? So true, right here, is coerced to 1, okay? And this true is also coerced to number 1, and they're approximately the same thing. Anyway, any questions on this, implicit coercion? Apart from all the questions you probably have about how weird this is. Okay, so here's the important part, right? We used string and number to convert into those things, right? You can also convert something into becoming a Boolean using the capital V. And you can convert this whole thing into a Boolean. And so this string is true. This whole string, when you force it to become either true or false, you have to pick, right? It's going to choose true. Okay? And what that means, right? We're gonna go through this, but what that means is this string is truthy. This string is truthy. What does truthy mean? That means if I try to take the string and I try to convert it to a Boolean, I'm gonna get true back, right? Imagine like Boolean is like a sorting hat for Harry Potter, right? Which club do you belong in? Does this thing belong in, right? And instead of there being 4 houses, there's only 2 houses, true or false, right? And because this thing ends up becoming true, we call it truthy. It is a member of the true house. It's a truthy thing. And the things that get coerced into becoming false are called falsy. Like actually, okay, truthy and falsy. So here it is. When coercing a value to Boolean, JavaScript uses rules to decide if a value should be coerced to true or false. Things that become true are called truthy. Things that become false are called falsy. So what does that mean? The vast majority of things in the JavaScript ecosystem is truthy. Okay, most things are true. That sounds like very philosophical, right? Most things are true, okay, in JavaScript. All of these things, they're all true, even like this big object, okay? Now, there's a limited set of falsy things. These are the only falsy values in JavaScript. And what are they? Empty string. I don't know why this only like explains the first one, right? 0, right? Null, undefined, or not a number. And actually there's one more, there's false, right? Literally the word false. But this is the only set of things in the entirety of the JavaScript universe that will be type coerced to false. And so these are the only falsy things. So most things are true, right? Everything that's not this is true. These are the falsy things. Yes?
Are most values like inherently true, or is that only after you use the capital Boolean function?
So most things are inherently truthy. As in, they're not literally true, but if they had to pick between true or false, they would associate themselves with true.
And you wouldn't need to use the Boolean.
And you wouldn't need to use the Boolean.
Okay.
Yes. And yes, exactly. We'll see how that implicit type coercion works into Boolean. Good question. So does this make sense? There's only falsy things. Everything else is truthy. Yes.
What does null mean exactly?
Null. It kind of means like nothing.
Yeah.
Which also undefined kind of means that too. But yeah, it means like nothing.
How is it different then?
I have no idea. It's like its own type. And so you might someone might want a function that returns null as a response instead of like undefined or something like that. But they're both very, very, very similar, to the point where there's a lot of new ECMAScript ES updates that will be treating these two as basically the same thing. But technically they're their own types. It's a little confusing. There was another question, maybe? Okay. Cool. And whenever you're like confused, just like, even without memorizing this, just like try to think, right? 0 is probably falsy. if you forget, just the number 0, that's probably false, right? Undefined. Okay, if I had to decide whether that thing is truthy or falsy, it's probably falsy. It's a little like negative, right? You can kind of guess. Empty string. There's nothing in the string. That's false, right? Okay. All right. So where is this all leading up to? So far we've seen conditional statements, right? We've seen if statements that evaluate to something that's literally true or false. And so in this situation, 5 is greater than 0. Is that true or false? It's true, right? So this is literally going to convert. I guess like this. There's not even conversion. This literally is just true, right? 5 is greater than 0. That's true. So we do this, right? Now instead, let's say we do this, right? If apples. That sounds bizarre, right? But it's actually totally valid. If you put something, right, into an if statement, and that thing is not explicitly true or false, what JavaScript will do is it's going to implicitly type coerce this thing into its truthy or into true or false, depending on whether it's truthy or not, right? And this string, which contains this, these characters, is that truthy or falsy? It's truthy, right? All strings are truthy unless it's empty, right? So since this is truthy, it's as if we're doing if true. And then so we don't go into this console log. Does that make sense? Okay. Cool. Awesome. More examples, right? So if the number 10, is the number 10 truthy or falsy?
Truthy.
It's truthy, exactly. So we're going to say yes. And then here, 0, is that truthy or falsy? It's falsy, exactly. So we put no. It's as if we're doing if false. Does that make sense? Cool. Okay. We're getting there. Now we have this operator, the exclamation mark, right? Also known as the bang operator. Also known as the not operator. Okay? The not. And what does that mean? That means, well, first of all, you put it in the beginning of something, right? You don't put it at the end, right? It's not like a sentence where you say true, right? You put it at the beginning. You also don't have to exclaim in any way, right? You put the thing in the beginning, and what that means is it's like you're saying not true, the opposite of that thing. You're flipping it, okay? So what's not true? False, right? What's the opposite of true? It's like opposite day. Boom, opposite day, okay? Now, here, if you put it in front of something that's like not explicitly true or false, right? What it's going to do is there's going to be some implicit type coercion, right? And ABC, is that truthy or falsy? It's truthy. Okay, so what's the opposite of truthy? False, exactly. And so on and so forth. Does that make sense? So it flips it, okay? Now, this could be useful if, let's see. Bless you. So if I have something like this, or say if, let's say user is over 21, right? And I'm going to say true. Or let's say whatever this is. It doesn't matter what this actually is, but let's say we have some variable, right, that holds onto a Boolean. And this Boolean says whether this user is over 21 or not. So if the user is not, right, if the user is not over 21, then we console log, I don't know, forbidden, or something like that. Does that make sense? So you have some variable that holds on to whether the user is 21 or not, yes or no. If the user is not over 21, right, then do something, right? Show them an error message or send them back to the home page or whatever it is. Cool. And then if they are over 21, right? If they are over 21, what does that mean? They are over 21, yes. So what's the opposite of true? It's false. So if false, that means we don't do this, right? False means we don't get to go in here. So that's good. So if they are over 21, we won't see this error message. Does that make sense? Okay. Cool. And the thing with this operator is you can chain it. You can have as many as you want in front of it. You can have 1 billion of these if you want. That'd be totally pointless. But you can do it as many times as you want. So not true. Well, what's not? Okay, hold on. What's not true? False. So what's not false? True. Okay, so it flips it like back onto itself, kind of, right? So what about this, right? So this is truthy. So not truthy is false, and then not false is true, right? So you might be like, well, what is the point of this, right? This is really, really, really helpful if you want to take something and determine whether it's truthy or falsy. So basically, I have number 100, and I want to know if it's truthy or falsy, specifically in the word as true or false. You know what I mean? And this is just a much shorter way of doing this. Let's predict this. And here, I do console log this. Okay? And then I console log capital Boolean 100. They're both going to be true, right? The opposite of something that's truthy is false. The opposite of that is true. Now, if I take this thing and I explicitly coerce into becoming Boolean, it's going to be true also, right? So both of these things actually do the exact same thing. Not, and the capital B Boolean do the exact same thing. This just saves time and energy. Cool. Does that make sense? Awesome. Okay, we're almost there. We're almost there. So logical operators. So I don't know if you've seen this before, but there are these things, and, right? Double ampersand. And what that does is it checks whether everything in that's in this, like that's surrounding this, right? Whether everything is true, okay, or truthy. Are 10 and 20, are they both truthy? Yes, right? They're both true things. And so this kind of evaluates to a truthy value, like everything is true. And so since they're both truthy, this will log. Okay. So let's go. Let's look at this real quick. So, is everything around these ampersands, are they both truthy? No, they're not. Right. And so it's false. We're saying if false, which means we go right here. Okay. So you can chain this also. Okay. And what this will do, right? What this is going to do is, it's going to check whether everything is truthy. Okay? And as soon as it finds something that's not truthy, all right? As soon as we find something that is not truthy, what does that mean? That kind of proves that that it's false to say that everything in here is true. right? We're trying to answer the question, is everything in here true? How do we disprove the statement, everything in here is true? All we have to do is we have to find one thing that's false. Okay? And that falsy thing is going to be returned here. And that's what's given here. And, okay, what if we have a situation where every single thing is truthy? Then we're just going to default to basically like the last thing that we just saw. Okay, we're going to start from here. And we go here and keep checking, is this false? Is this false? Is this false? Right? We didn't find anything that was false. We ended up here. So that's given here. And we return it. Same thing here, right? I'm going to keep looking until I find something that's falsy. Is this falsy? No. Nope. Oh yeah, I found something that's falsy. Okay, that's returned here. And then that's basically it's either the first falsy thing, right? If we find something that's falsy, or the last truthy thing, if everything's truthy.
So if like null was switched with 0, then you'd output null?
Yes.
Okay.
Yes. Good point. If this is switched, the first thing we find that's falsy is null, right? So that's that. This was really confusing for me at first, so like don't worry if it's weird. Think of it.
Like, what's the use case for this?
Yeah, that's a good question. So, great question. So, what if, right? I had I'll start with an analogy, okay? So let's use apples, right? Let's say I have a bucket. I had a bucket of apples, right? And one bad apple spoils all of them, or whatever, right? So how are we gonna check if the apples are worth eating? You're basically gonna check, are all of these apples good? How do you check if all these apples are good? You have to look through every single one, right? When are you gonna know that there's something bad? As soon as you find the first bad thing, right? Boom, that thing's bad. That's the return value. That's the falsy thing, the falsy apple. And if your entire bucket of apples, they're all good, how can you prove that? The only way you can do that is to look through literally every single apple and not find anything that's bad, okay? So that's kind of like how to derive something out of this chain, right? You're looking for a bad apple. Now, where this might be useful, right? Where this might be useful is each one of these things, right, could represent like let's say a person, right? Think about it this way. You're at a restaurant. You're at a restaurant and you want to order drinks, right? And some restaurants, like if every single person in that room isn't over 21, they won't serve you. Right? Every single person has to be over 21. If one person under 21, like they're not going to bring drinks out at all. And so if you might have some sort of logical operation that checks that in an automated way, right? If you're a group and you're all like making a reservation or something, there's going to be some program that goes through does every single user pass a certain condition? And if any one user out of that group, right, there's some flag on it, like they're on like some watch list or something, then that entire group is invalidated. Does that make sense? You're booking Airbnb as a group, right? And you find out that one user has like a lot of reports about them, so then the whole reservation is invalid. Yes. Yeah.
So I guess what I'm confused about is that this isn't necessarily telling us if it's valid or invalid. It's just giving us the output of like what could, so like return value 1. It's telling you it's 0, but then
Yes.
we have to go do the extra step of then determining
Whether that's truthy or falsy.
whether that's true or false.
You're exactly right. You're exactly right. But the thing is, because 0 is inherently falsy, you can take this and you can put this directly inside of an if statement. You can put this in an if statement, right? So, let's do this. So if I do if this, right? Then console log, they are all good. Okay. Else console log found something bad. Okay. So here we say found something bad. How did this happen, right? It's because this whole chain returned the first falsy thing that it found, right? So it's as if we're doing if 0. So this whole thing gets converted to literally 0. What happens if you do if 0? 0 is falsy, right? So we can just go right here. Same thing here. And so let's say true. And they're all good. Yes.
So this is only good like for the occasion where even if this one thing is bad, we don't want to look at anything else.
Exactly.
Okay.
Exactly. So again, like I'll keep giving examples because this is like really good to just think about how this works in the real world. At Coinbase, when we want to allow people to trade, right? What we want to do is if what was it? User has like signed agreement, right? And user is over 18. I think that's our like limit. And like user is not on government watch list. There actually is a public watch list. It's like tens of thousands of names that we can't give accounts to, right? If all these things are true, right? Like allow trading or something like that, right? And so this, if any one of these are false, if they haven't signed an agreement, doesn't matter that they're over 18, doesn't matter that they're safe. They haven't signed an agreement. So you like remind them to do that. And you can take this whole thing and you can store it as a variable, right? And you can say const like can trade equals this whole thing. And so if they can trade, allow them to trade. Okay, cool. And you can like mix it up and say like, okay, if the user is not, right? If the user is not on the watch list or something like that, you can mix it up. Okay. We're almost there. Also, my computer's dying, so I have to finish this soon. Actually, I'm gonna ask to borrow a charger from one of you guys in a bit. Okay. Last logical operator. The or. This is very similar to the and, in that it's the exact opposite. This will basically check if just one of the things in this list is truthy. Okay? The and, right, looked for the first falsy thing, right? If any, right? Here we're going to look for the first truthy thing, okay? Is this truthy? Nope. Is this truthy? Nope. Is this truthy? Yes. Great. So that's returned here, and that's good, right? So this is like, are any one of these things truthy or not? Yes or no? If any one of these things are truthy, then let's push forward, right? Is the user, right? Like, did they complete setting up their account, or are they gonna pay us $100 million, right? If any one of those things are true, let's let them go through. So let's say they haven't been verified, but they're gonna pay us a lot of money. Let's just let them go through, right? You don't have to satisfy every single one. You just have to satisfy one of them, okay? And here, if, you know, in a situation where none of these are truthy, right? 10 is less than 0, right? That's not true. Not a number, that's falsy. We return the last thing that we saw, right? And the last thing was not a number. Does that make sense? So this is, the OR operator is, are any one of these things true, right? This is, are any one of these things false? Okay, there's a lot of different ways to think about this. Okay, so that was it. Explicit quotient, implicit, don't use double equals, right? Concatenation, the plus sign, be careful with the plus sign. Don't even use the plus sign, unless you know for sure that everything's a number, right? Or if you wanna, if you're for sure that everything's a string and you want to just like build up the string, right? So be careful here. Just avoid this, and then the truthiness. So everything is inherently either true or false, right? In the end, just like the universe. And then conditional expressions. So if you put something that's not literally true or false into an if statement, the if statement will implicitly tie coercion to becoming either true or false. This flips something, flips the truthiness of something, and then logical stuff we just went over. Are there any questions on any of this stuff? Cool, so you know it perfectly. And this workshop will be really easy, it's perfect.